So our goal is to use deep neural network to remove noise from the noisy signal. The first neural network we use is CNN. Figure 1 shows the structure of CNN. It has 27 layers. The first layer is an image input layer of size 30,000 times 1 times 1 with zero central normalization. So 30,000 is the number of samples per input ECG signal, and that means we need to resample our signal to 3000 Hz with duration 10 seconds. We also need to reshape dataset from 1D to 4D in order to use image input layer. This module also has 6 two-dimensional convolution layers, each having 36 filters with kernel size of 90 times 1 per filter. Each convolution layer has nanos that connect to parts of the input feature or connect to the output of previous layer. The second neural network we use is based on the lstm layer. The module has 7 layers. The first layer is a sequence input layer with input size 30,000. The module consists of 2 lstm layers with 140 hidden nodes per layer. The lstm layer has nanos that connect to the input layer and the ReLU layer. For the software, we have used MATLAB 2021b version. For the add-on, the team needs to install Deep Learning Toolbox and the Signal Processing Toolbox before running the code. For the implementation steps, the first step is to load dataset and do data preprocessing. This step contains resample frequency to 3000 Hz and reshape dataset from 1D to 4D. The second step is to divide dataset into training and testing, 75% for training, 25% for testing. Then we define module architecture and set training option and start training. Table 1 and Table 2 shows details of training parameters. The last step is to test module using test dataset and see if the module can remove noise from the signal. So I'm going to show you a demo video of our CNN module. We use white Gaussian noise as our input data. Running the code. It is normalizing input data. Now it will begin training. So here the first graph is mini batch RMSE. The second graph is for mini batch loss. As you can see, the RMSE is going down and also loss is going down. After 40 epochs, the mini batch RMSE is about 2.69. And this is the output for one of the text signal. The first plot is noisy data with white Gaussian noise. The second plot is what we predict. We can clearly see the white Gaussian noise has been removed. For another case, we use artificial noise as our input. We use 7 steps and training. As you can see, the RMSE plot is rougher compared to last one. This is because the artificial noise is real data and it is more inconsistent than white Gaussian noise. And this is our test result, and the artificial noise has been removed.